Welcome to the deep dive. Today, we're looking past the usual picture of, a single AI doing its thing. We're diving into some really fascinating new research about what happens when AI agents actually interact with each other, specifically large language models like ChatGPT.
Mhm.
And what's really surprising, honestly, is how human-like the results seem to be. This study suggests maybe our view of AI as these isolated, solitary things might be missing something really big.
That's a great way to put it. Yeah, traditionally, AI research tends to focus on what one AI can do, its individual skills.
Hmm.
But this work, it's a collaboration, actually, between City St. George's, University of London, and the IT University of Copenhagen. It asks this really fundamental question. Can these AI agents, without any explicit instructions, coordinate their actions? Can they create their own sort of communication rules, their own conventions, almost like human societies do? So the core idea we're exploring today is this concept of AI self-organization.
Okay, right. So let's get into how they actually tested this. The researchers, I think the lead author was Ariel Flint Ashry, and Professor Andrea Barron Kelly was the senior author. They didn't just let a bunch of chatbots loose, right? It sounds like they set up a pretty specific experiment.
They did, yeah. It was quite cleverly designed. They used groups of these LM agents. The group sizes varied, sometimes 24, sometimes up to 100. And in each experiment, they'd randomly pair up two agents.
Okay.
And the task was pretty simple on the surface. Choose a name, which could just be a letter or maybe a short string of characters from a list of options they were given.
Ah, okay. And I read there was a reward system
Mm.
to kind of nudge them towards agreeing.
Exactly, that's crucial. If
Yeah.
the two paired agents happened to pick the same name, boom, they both got a reward. But if they picked different names, there was a penalty. And this is really important. They were shown what the other agent had picked.
Ah, so there's a feedback loop.
Precisely, a feedback loop. But what's really fascinating and maybe a bit counterintuitive is that these agents, they had no idea they were part of this larger group. And their memory was super limited, and they basically only remembered their most recent interactions, not the whole history.
Wow. Okay. No group awareness, short memories.
Yeah.
You'd almost expect that to just result in, randomness, right? Complete chaos. But that's not what happened.
Not even close. This is the core finding. Even with no pre-programmed solution, no central coordinator telling them what to do, shared naming conventions just sort of emerged. They popped up across the whole group.
Seriously, just like that.
Just like that. Think about it. Individual agents only talking to one other agent at a time with barely any memory. Somehow, collectively, they started to agree on using certain names much more often than others. So the really big insight here is that AI, even without us programming it in, can self-organize. It can create shared meaning, which really challenges the idea that AI behavior is purely, deterministic based on its code.
It's almost like they started to, I don't know, understand each other on some basic level
Yep.
without being explicitly taught a language. That reminds me of the example Barron Kelly used, the word spam.
Exactly. That's a perfect analogy he brought up. He pointed out, no committee ever sat down and formally defined spam for the internet. But through millions, billions of individual interactions, people emailing, people complaining, the word just came to mean unwanted electronic messages. Everyone gets it. The AI agents here were doing something similar, obviously on a much, much smaller scale, but that basic principle, shared understanding emerging from repeated coordination, it's the same.
Okay, that makes sense. But it wasn't just about agreeing on a name, was it? The study also mentioned collective biases forming. What does that actually mean in this context? A bias in choosing a letter.
Yeah, basically. It means that certain naming conventions, certain letters or strings became way more popular within the AI group. But the crucial part is this preference couldn't be traced back to any inherent bias in the individual AI agents. You couldn't point to one agent and say, it likes the letter Q. It was a property of the group itself, something that arose purely from the interactions between them.
Oh.
So the key takeaway there is pretty significant. Group dynamics themselves can create biases that just don't exist when you look at the AIs individually. That's really important for thinking about unintended consequences in bigger, more complex AI systems.
That is a bit mind-bending, yeah.
Yeah.
Individual agents are neutral, but the group somehow develops a preference together.
Mm.
And then there was that final experiment you mentioned about small groups influencing the bigger one. How did that part work?
Right. So for that, the researchers took a small group of agents that had already settled on a particular naming convention amongst themselves. They then introduced this coordinated little group into the larger population of agents who might have had a different convention or none at all. And they watched what happened.
Did the little group get drowned out? Or?
Well, what they found was pretty amazing. If that small coordinated group was large enough, if it reached a certain size, a critical mass, it could actually sway the entire larger group. It could effectively push the whole population towards adopting its preferred naming convention.
Wow, that sounds incredibly familiar, actually, like how trends or social movements catch on in human society. A relatively small but committed group can sometimes shift the behavior of the majority once they reach a certain tipping point.
Exactly. That's precisely the concept, critical mass dynamics.
Huh.
It shows that even within a large AI system, a smaller, unified subgroup could potentially steer the behavior of the whole network. And if you think about the implications, well, it's significant for how we might manage or interact with future AI systems that are made up of many, many interacting parts.
Right, and this leads directly into the AI safety concerns that Professor Baron Kelly raised.
Yeah.
It's suddenly not just about making sure individual AI models are safe or unbiased anymore. We have to think about the group dynamics, the AI society almost.
Precisely. Baroncelli framed this research as opening up a new horizon for AI safety research. His point is that we need to understand how these interacting systems operate because, as he put it, we're moving into a world where AI isn't just, processing information in isolation. He said AI does not just talk, it negotiates, aligns, and sometimes disagrees over shared behaviors, just like us. Understanding that negotiation, that alignment, that disagreement, that's going to be critical.
So, the worry is that these AI groups could develop their own norms or behaviors that maybe we didn't intend and perhaps couldn't even predict just by looking at the individual AIs.
That's definitely part of the concern, yeah. Could emergent group level behaviors lead to unforeseen problems? Problems our current safety models, which often focus on single agents, might miss entirely. It's a really important question.
Which means looking at AI just on its own isn't giving us the full picture anymore. We absolutely have to consider the social dimension, the collective stuff that happens when they talk to each other. Ariel Flynn Ashery, the lead author, also really stressed this, right? That this research is different because it treats AI as a social thing, not solitary.
Yes, absolutely. Ashery highlighted that this is becoming more and more relevant to the real world as we see more interconnected AI systems being deployed. And the key point is that the collective behavior isn't just predictable by adding up what each individual AI does. It's more than the sum of its parts. Something new emerges from the interaction itself. It really underscores the complexity we're likely facing as AI gets woven more deeply into everything and starts forming its own, well, internal networks.
Okay, so let's just sort of recap the main takeaway here. This study basically showed something pretty remarkable when you say that AI agents, just by interacting, can spontaneously cook up their own communication rules, their own social dynamics that actually look quite a bit like how humans do it.
Uh-huh.
It's genuinely surprising that these norms and even collective biases can just emerge organically without anyone programming them in, just from the simple process of trying to coordinate.
It really is a fascinating piece of work. It forces us, I think, to adjust how we think about AI behavior.
Yeah.
We have to start accounting for these emergent properties that come from AIs being interconnected.
Definitely. And that leads us to a final thought for you, the listener, to maybe chew on. As these AI systems inevitably become more interconnected, Baroncelli suggests this is the direction we're heading. How are these emergent social behaviors going to shape our future living alongside them? What kinds of unforeseen norms or maybe even biases might bubble up within these AI societies? And crucially, how might those end up influencing us? It's certainly something worth thinking about. Thanks for taking this deep dive with us today.